Hello viewers, in today's session we are going to discuss a very important problem from derivatives, right? And here we have to find the value of g prime of 1 if the function g of x is given as the product of two functions, that is x raised to 4 times h of x cube, right? So here h of x cube is some other function and g of x is the product of these two functions, right? And here we are given that h of 1 is equal to 2 and h prime of 1 is equal to minus 3, right? So here we have to find the derivative of g of x at this point, that is x is equal to 1. So for this, what we will do, we'll find out the derivative of g of x, right? So g prime of x is given by the derivative of x raised to 4, and here we have h of x cube, right? So here we have the product of two functions, so we can make use of the product rule for derivatives. So the product rule, it goes like this: if we have two functions, say u and v, and u and v are functions of x, so we have first function, then the derivative of second function, then we have the second function and derivative of first function, right? So here we can make use of this product rule to differentiate this product, right? So we can take x raised to 4 as u and h of x cube as v. So we have first we can write x raised to 4, then we have the derivative of h of x cube, and then we have h of x cube and the derivative of x raised to 4, right? So now we have x raised to 4, and here we have to differentiate h of x cube with respect to x. So what we will do, we can make use of chain rule here. So we can first differentiate h of x cube with respect to x cube, and here we can write h of x cube, and then by chain rule we can differentiate x cube with respect to x, and here we have h of x cube, and here x raised to 4 is to be differentiated with respect to x, and the derivative is 4x cube, right? So we have x raised to 4, and here the derivative of h of x cube with respect to x cube is h prime of x cube, and here we can write the derivative of x cube as 3x square, and here we have 4x cube and h of x cube. So now we can write this expression as 3 times x raised to 6, 4 plus 2 is 6, and h prime of x cube, and here we have 4x cube and h of x cube, right? So this is the derivative of g of x. So now to get the value of g prime of 1, we can take x is equal to 1. So g prime of 1 is equal to 3 times 1 raised to 6, and here we have h prime of 1 cube, because x is equal to 1, and here we have 4 times 1 cube, h of 1 cube, right? So this is 3, this is 1, and here we have h prime of 1, then we have 4, and here we have 4 times h of 1, right? Now we have h prime of 1 is equal to minus 3. So we can now substitute the value of h prime of 1, that is minus 3, and then we have 4 times h of 1, and h of 1 is given as 2. So now we have minus 9, and this is 4 times 2, 8. So 8 minus 9 is minus 1, right? So the value of g prime of 1 is equal to minus 1 when we are given this function along with the conditions h of 1 is equal to 2 and h prime of 1 is equal to minus 3. Hello viewers, in today's session we are going to discuss another important and conceptual problem from integrals, right? And here we are given this problem in which f of x is a polynomial function such that f of x square minus 1 is equal to x raised to 4 plus 5x square plus 6, and we have to find the definite integral of f of x from 0 to 1, right? And remember here f of x is a polynomial function, and the function f of x square minus 1 is given by this polynomial, that is x raised to 4 plus 5x square plus 6, which is defined for all values of x belonging to the set of real numbers, right? And we have to find the value of this integral, right? So what we have to do in this problem, see here the integrand is the function f of x, but here we are given f of x square minus 1. So what we will do, we'll first find out an expression for f of x. So our objective is to get the value of f of x in terms of x, where we are already given f of x square minus 1 is equal to this expression. So here what we can do, let us try to write this expression in terms of x square minus 1, right? See, we have f of x square minus 1 is equal to x raised to 4 plus 5x square plus 6. So now we can write x square minus 1 whole square as x raised to 4 minus 2x square plus 1, right? So here x raised to 4 minus 2x square plus 1 can be created over here, right? So we can write here x raised to 4, then we can write minus 2x square plus 1 such that this quantity remains the same, right? So here we have x raised to 4, then here we have minus 2x square, but here we have 5x square. So what we have to do, we have to write here 7x square, because 7 minus 2 is 5. So we have to add 7x square, and here we have 6 and we have already 1 here. So we can write here plus 5, so that 5 plus 1 is equal to 6, right? So now this trinomial can be written as x square minus 1 whole square, and here we have 7x square plus 5, right? Now let us try to express this term in terms of x square minus 1. So we can write x square minus 1 whole square, and here we can write 7 times x square minus 1, because we have 7x square, then we have 7 times 1 as minus 7, but here we have 5, right? So to compensate, what we have to do, we have to add plus 12, so that 12 minus 7 is equal to 5. So here we can write 12. So we can now have 7x square, 7 times 1 is minus 7 plus 12, and minus 7 plus 12 is equal to 5. So this term and this term are equivalent. So now we can write x square minus 1 whole square, and here we have 7x square minus 1 plus 12. So the expression for f of x square minus 1 in terms of x square minus 1 is given by this one, right? So here we can see that the input is x square minus 1. So now let us denote this term, that is x square minus 1, as say p, right? So we can now write f of p as p square, because we are taking x square minus 1 as p, and here we have 7 times p plus 12, right? So now here we have f of p is equal to this trinomial in terms of p. So now our aim is to find out the value of this integral, right? So we can now write the integral 0 to 1 f of p and dp as 0 to 1 f of x dx, right? So here we have used the property of dummy variable in definite integrals, because we know this property of definite integrals. If we have the limits from a to b, and here we have say f of x dx, then this integral is equal to a to b f of t dt, right? So we can change the variable, or this variable is known as the dummy variable, right? So this property is very useful while evaluating the definite integrals, right? So 0 to 1 f of p dp can now be written as 0 to 1 f of x dx. So now we can write 0 to 1, and f of x can be written from this expression by replacing p by x. So here we have x square, and then we have 7x plus 12, and this is dx. So now we can easily evaluate this integral, and we can now write the integral of x square as x cube over 3. Then the integral of x is x square over 2, and then we have 12 here, and the integral dx is simply x, and the limits are from 0 to 1. So now substituting the limits and taking the difference, first we'll take x is equal to 1 here. So we have 1 cube over 3. Then we have 7 over 2 times 1 square. And here we have 12 times 1. And then we can take x is equal to 0 here. So this term becomes 0, this term becomes 0, and this term is also equal to 0. So here we have 0 plus 0 plus 0, right? So now we have 1 over 3, then we have 7 over 2, and this is 12. Now we can take the LCM. We can simply add these three numbers. So we have 6 here, and then here we have 2. Then we have 3 times 7, that is 21, and then 12 times 6 is 72, right? And the sum of these three terms is 5 here, then this is 9, right? So this is 95 over 6. So the value of this integral is equal to 95 over 6. Hello viewers, in today's session we are going to discuss another important and very conceptual problem from derivatives, right? And here we have this problem in which we have to differentiate this function, that is sine inverse of 2ax times square root of 1 minus a square x square with respect to another function, say square root of 1 minus a square x square, where this condition is given, that is minus 1 over square root of 2 is less than the product of a and x, and ax is further less than 1 over square root of 2, right? So this problem belongs to the category of problem that is known as finding out derivative of one function with respect to other, right? So here we have to find out the derivative of this function with respect to this one. So what we will do, we'll take this function as say u, and u is sine inverse 2ax times square root of 1 minus a square x square, and we can assume this function as v, right? And here we have square root of 1 minus a square x square, and see, we have to find du over dv, that is the derivative of this function u with respect to this function v, right? So here to get the derivative du over dv, we can make use of the method of substitution, right? So here we'll make use of one important trigonometric substitution. So let us assume here this quantity, that is ax, as equal to sine theta, right? So that x is 1 over a sine theta, and if we substitute ax is equal to sine theta in u and v, then let us see what we get. So u is now equal to sine inverse, and here ax can be taken as sine theta. So we have 2 sine theta, and here we have square root of 1 minus ax square. So this term is ax whole square, and ax is sine theta, so we have sine square theta, right? So we have sine inverse, and here we have 2 sine theta, then square root of 1 minus sine square theta is simply cosine theta, right? This is from trigonometry. So we have u is equal to sine inverse, and this is the double angle formula for sine 2 theta, because sine 2x is equal to 2 sine x cos x, right? So here we have sine 2x, and now this sine and this sine get cancelled using the principal value branch of sine inverse function. So u is equal to 2x. Here we are taking theta, so this is theta. So here we have simply u is equal to 2 theta, right? So let us differentiate u with respect to theta. So we have du over d theta is equal to d by d theta of 2 theta. So this is 2 times 1, because derivative of theta with respect to theta is 1. So here we have 2, right? So du over d theta is equal to 2. So now let us substitute ax is equal to sine theta over here. So again we have v is equal to square root of 1 minus a square x square, which is ax square, that is sine square theta, right? And 1 minus sine square theta is cos square theta, so this is simply cosine theta, right? So let us differentiate v with respect to theta. So we have dv over d theta is equal to minus sine theta, because the derivative of cosine theta is negative of sine theta, right? And sine theta is equal to ax, so here we have minus ax, right? So now we have dv over d theta is equal to minus ax. So now this derivative, that is du over dv, can be written as du over d theta divided by dv over d theta, right? So here we are finding out the derivative of one function with respect to other, right? So this is our first function u, and this is our second function v. So first we find the derivative of u with respect to this theta, and then we have the derivative of v with respect to theta. So now we can substitute du over d theta as 2. So here we have 2, and dv over d theta is minus ax, right? So the derivative of u with respect to v is given by 2 divided by negative of ax.